Our objective in this lesson is to determine domain and range, including the domain and range of polynomial and radical functions. So what are domain and range? Domain is the set of all possible values for x, while range is the set of all resulting values of y. There are several ways on how we could write domain and range. First one is through roster method. This is listing or enumerating all the values. It uses braces. Here are the examples. Next one is interval notation. It uses parentheses and brackets. Here are the examples. I'm going to tell the difference of using these two as I go along with the examples later. And the third one is set builder notation. It uses braces and a vertical line. Here are examples. This is read as x is an element of real number such that x is less than -1. Others write in this manner. X such that x is an element of real number where x is less than -1. Either of the two is correct. Let us determine the domain and range when the given is in a set of ordered pairs. Number 1. For domain, simply look at the x values and then enumerate them. So we have 2, 4, 7, 10, separated by comma and enclosed by braces. For the range, simply look at the y values. So we have 7, 8, 11, and 20, again separated by comma and enclosed by braces. Number 2. For the domain, we have -5, 0, -6, 11. When we write the domain and range, let us arrange the values in ascending order. So the first one will be -6, -5, 0, and then 11. Now for the range, we have -3, 0, 17, -25. So the first one will be -25, then -3, then 0, then 17. Another one. For the domain, we have -8, -8, 1, 2, 3. When the values are repeated, we simply have to write it once when writing the domain and range. So the domain will be -8, 1, 2, 3. Now for the range, we have -4, 0, -5, 0, -4. Remember to list the values just once. So we have -5, -4, and 0. Now let us have table of values. This is much easier. You can easily see the group of x and y. So let's have the domain. We have -2, -1, 0, 1, and 2. For the range, we have -4, -2, 0, 2, and 4. Let's have another one. For the domain, we have -3, -1, 4, 0, -1. Remember to list -1 just once and arrange it in ascending order. So we have -3, -1, 0, and 4. For the range, we have a single value. So range is 8. Next one. For the domain, we have -8, -1, 7, 2, -1. So list -1 just once. So we have -8, -1, 2, and 7. And for the range, we have -9, -4, 0, and 2. Now for the mapping diagram, this is like table of values. The first group is x and the second group is y. So let's have the domain. 1, 2, 3, 4. And here the range is 5, 6, and 7. Another one. Our domain will be -1, 1. And our range will be 5, 6, 7. Next one. Our domain will be -2, 1, 3. Remember, ascending order. And our range will be 5, 6, 8, and 11. Now for the graph. If you are not yet used in determining the domain and range by simply looking at it, I suggest you make use of colors. Let me show you. So for the domain, we are going to shade the area of the graph coming from the left to the right. So, use first C color from -4 that corresponds to this point, ends at 2 that corresponds to this point. Meaning, your domain is from -4 to +2. So, we write it this way. We make use of brackets because the two endpoints are shaded circle, meaning they are included. Other teachers prefer writing in set builder notation. I'll teach you how. So, x is an element of real number such that. Negative 4 will be our left limit and 2 our right limit. So we first write negative 4 close to the vertical line. And then 2 somewhere on the right. Then since this is bracket, we make use of less than or equal to, so close to negative 4. Then this is also bracket, so less than or equal to also, close to 2. And then write x at the middle, and finally enclose your domain. So this is read as x is an element of real number such that x is less than or equal to 2, but greater than or equal to negative 4. Meaning, your domain is from negative 4 to positive 2 only. Which is correct because you don't see any graph in here as well as in this portion. Now, let's talk about the range. For the range, you're going to start at the minimum level, going up. So, in the y-axis, the minimum is at the bottom and the maximum is on the top. So, we're going to color the area of the graph from negative 2 to positive 4. So, your range is from negative 2 to positive 4. We write it this way. Again, brackets because the two endpoints are shaded circles, meaning they are included in the solution set. Now, for the set builder notation. So, y is an element of real numbers because we are talking of range, that is y. Such that, so, negative 2 close to the vertical line, then 4 somewhere on the right. This is bracket, so less than or equal. This is also bracket, less than or equal. And then y. Then close your range. So it means your y ranges from negative 2 to positive 4. It's here, from negative 2 to positive 4, which is correct. You don't see a graph here as well as in this portion. Let's have another one. Again, for the domain, we shade coming from the left, going to the right. So you first see shade here that corresponds to this point, and ends here that corresponds to this point. Now, notice that this is shaded circle and this is open. So we write it this way. For shaded circle, bracket. For open circle, parenthesis. In set builder notation, that will be, so 0, and then 6, since this is bracket, less than or equal, since this is parenthesis, less than only. And then x at the middle, and enclose your domain. So your domain is from 0 to 6 only. You don't see graph here as well as on this portion. Now for the range. So from the minimum point, which is negative 4, up to the maximum point, which is 12. Again, this is shaded and this is open. So we write it this way. So bracket for negative 4, shaded, and then for 12, parentheses, because this is open. Set builder notation. So we have negative 4 close to the vertical line, then 12 somewhere on the right. For bracket, less than or equal. For parentheses, less than only. And then y at the middle because this is range. And then enclose your range. Let us have another one. So for the domain, we start coloring from left to right. But this is a little bit tricky. See these arrowheads here? It goes infinitely downward. And as the graph goes infinitely down, the width of the parabola goes wider too. So it means if this goes down infinitely, the width goes wider and wider as well. So there is no beginning and no end. Therefore, the domain is from negative infinity to positive infinity. This is much easier to write in set builder notation. So x such that x is an element of real number. Now for the range, we color from the minimum going to the maximum point. So since this has no end, so it came from negative infinity up to, look at your y, up to 0. So negative infinity to 0. For the set builder notation, that would be values of y that is less than 0. So y is an element of real numbers such that y is less than or equal to 0. There is or equal because this is not open. So that is included. Another one. So for the domain coming from the left going to the right. So look at your x-axis. You first see color at 0. And take note that it is open circle. Going to the right, see that arrowhead? It means it has no end. So the domain will be 0 to positive infinity. Parenthesis because this is an open circle. And then since there is an arrowhead, it goes infinitely to the right. So to positive infinity. Infinity, we also make use of parenthesis. So in set builder notation, it means these are values of x that are greater than 0. For the range, we'll start coloring from the minimum going up. So look at your y-axis. You started seeing a graph at 2 and then it goes upward. So from 2 to positive infinity. So for set builder notation, these are values of y that are greater than 2. Now let us talk about domain and range in equations. So number 1, y is equal to 2x. To determine the domain, solve for y. Our only restriction here is if we will be having a denominator. The denominator must not be equal to 0. So y is equal to 2x. We do not have denominator here. So therefore, we don't have restriction. So our domain is from negative infinity to positive infinity, or set of all real numbers. To determine the range, let us solve for x. So again, our restriction is the denominator must not be equal to 0. So y is equal to 2x. To solve for x, we divide both sides by 2. So this will become x is equal to y over 2. We have a denominator here, but it is not a variable. It's a constant. So there is no value that can make our denominator 0. Again, we do not have restrictions. So our range is from negative infinity to positive infinity. Let us have another one. Negative 2x plus y is equal to negative 8. To determine the domain, let us solve for y. So negative 2x plus y equals negative 8. Moving negative 2x to the other side, it will become positive. So y equals 2x copy minus 8. Again, we do not have denominator, so no restrictions. Our domain is negative infinity to positive infinity. For the range, let us solve for x. So negative 2x plus y equals negative 8. Let's move y to the other side. Negative 2x minus y, copy minus 8. Let us divide both sides by negative 2. So this time we have a denominator, but again, this is not a variable. It's a constant, so no restrictions again. So our range will be the set of all real numbers. Number 3, y minus 1 is equal to x squared. So this is actually quadratic. To determine the domain, let us solve for y. So let us move negative 1 to the other side. Y equals x squared plus 1. We do not have denominator, so it means we do not have restrictions. So our domain is the set of all real numbers. For the range, let us solve for x. So y minus 1 is equal to x squared. Let me switch the position. In solving, we are used that the unknown is at the left side. So let us take the square root of both sides. This will become x equals the square root of y minus 1. Since I have a square root here, the value of my radicand should be greater than or equal to 0. Because if this is negative, the square root of negative is imaginary. So all we have to do is to set our radicand greater than or equal to 0. Moving negative 1 to the other side, y is greater than or equal to 1. This will now be our range. Now, how do we write that in interval notation? So you start from 1, going to positive infinity. There is or equal, so we make use of bracket. 1 to positive infinity. Number 4, y is equal to 3x squared minus 4. This is actually a quadratic function. And if it is quadratic function, the domain is always the set of all real numbers. Now for the range, let us solve for x. So y is equal to 3x squared minus 4. Let us move negative 4 to the other side. Y plus 4 equals 3x squared. Let us switch places. And then we divide both sides by 3. So we have x squared is equal to y plus 4 divided by 3. Then take the square root of both sides. So this will become x equals the square root of y plus 4 over 3. Then we set up our radicand greater than or equal to 0. To eliminate this 3 here, let us multiply both sides by 3. So this 3 will be cancelled out. Then 0 times 3 is 0. So you have y plus 4 greater than or equal to 0. Move positive 4 to the other side. Y is greater than or equal to negative 4. This will be our range. Now, in interval notation, you'll start with negative 4 going to the right. So from negative 4 to positive infinity. Why bracket? Because there is or equal to. Number 5, y is equal to the square root of x minus 5. So this is a radical function. So to determine the domain, let us just set the radicand greater than or equal to 0. So we have x minus 5 greater than or equal to 0. Let's move this to the other side. X is greater than or equal to 5. This will be our domain. So for interval notation, you'll start with 5 and then going to the right. So that means 5 to positive infinity. So because there is or equal, we'll make use of bracket. Now for the range, let us use the limits of the domain. Let's start with the lower limit. So let's copy the function and then we substitute our lower limit, which is 5. So y is equal to the square root of 5 minus 5. Y is equal to 5 minus 5 is 0, is square root of 0. And square root of 0 is 0. Now for our upper limit, let's copy the function again. And this time, let's substitute positive infinity. So y is equal to the square root of positive infinity minus 5. A very big number minus 5 is still a very big number. And a square root of a very big number is still a very big number. So our lower limit is 0. Our upper limit is positive infinity. This will be our range from 0 to positive infinity. So in set builder notation, that would be values of y that are greater than or equal to 0. Number 6, y is equal to negative square root of 10 minus 2x. So for the domain, let's set our radicand greater than or equal to 0. Let's move 10 to the other side. So we have negative 2x greater than or equal to negative 10. And then we divide both sides by negative 2. Negative 2x divided by negative 2 is x. Negative 10 divided by negative 2 is positive 5. But since we divide by a negative number, our inequality symbol will change. So final answer, x is less than or equal to 5. This will be our domain. So our domain, 5 going to the left. But since we write from a lower value, this will be from negative infinity to positive 5. So there is or equal to, so you'll make use of bracket. Now for the range, let's use the limits of the domain. Let's start with the lower limit. So we're going to substitute negative infinity for x. So we have y equals negative is square root of 10 minus 2 times negative infinity. So 2 times negative infinity is still a very big negative number. But negative of negative will become positive infinity. So y equals negative is square root of 10 plus infinity. And 10 plus a very big number is still a very big number. So y equals negative is square root of infinity. And square root of a big number is still a big number multiplied by negative. So you have y equals negative infinity. Now for the upper limit, let us substitute 5 this time for x. So y equals negative is square root of 10 minus 2 times 5. 2 times 5 is 10. So 10 minus 10 is 0. So y equals negative is square root of 0. And square root of 0 is 0. So y equals negative 0. But we do not have negative 0. So y equals 0. So our lower limit is negative infinity and our upper limit is 0. So from negative infinity to 0. So in interval notation, this will be values of y that are less than or equal to 0. Here are some tips about domain and range. Number 1, when the relation is given in ordered pairs, table of values, or mapping diagram, use raster method in listing the domain and range. The domain is the set of all x coordinates, and the range is the set of all y coordinates. Number 2, in graph, look from left to right to determine the domain, and for the range, start looking from the minimum y value going up. Number 3, the domain of polynomial function is always the set of all real numbers, whether linear, quadratic, or cubic. Number 4, to get the domain of radicand function, set up the radicand greater than or equal to 0 and solve. Now, it is time to check your understanding. Pause this video if you need more time. Here are the correct answers. For number 1, set up the radicand greater than or equal to 0. So the lowest possible value is 0. So domain is 0 to positive infinity. Same thing with the range, 0 to positive infinity. Now for number 2, we have 2, negative 1, 2, and 0. 2 was repeated. So we have negative 1, 0, and then 2. Remember to arrange your values in ascending order. For the range, we have 3, 2, negative 4, and 0. So we have negative 4, 0, 2, and then 3. For number 3, this is a linear function. It's a kind of a polynomial. So both domain and range are from negative infinity to positive infinity, or set of all real numbers. And for number 4, looking at the x-axis, we first saw a graph at x equals 0. And then since this will go infinitely upward, then this width will also go infinitely wider. So from 0 to positive infinity. And for the range, from the minimum value, which is negative 5, going up, so negative 5 to positive infinity. Gets?